looks, I'm not going to do a very good job, but we are supposed to compare f double prime, or sorry, f prime of -1 and f double prime of 1. All right, let me draw the pink one up here, sort of looks like this. Okay, and this is 1. Or the red, pink, whatever. And then the blue one looks like that, positive to here, -2 there, positive, okay, ish. Now, we have to figure out, it says one's F prime. So I think we all kind of agreed that the blue one was F prime, and the red or pink, whatever you want to call it, is F. Is that correct, everybody? Okay, so we don't have F double prime, so again, you're going to have to think about something else. All right, so F prime of -1. Where's -1 on this graph? Let's see. It looks like it's about on the F prime of -1, looks like it's over here. Would you agree? If you look at the graph, that's where I have it marked. So F prime of -1 is about right here. Is that what you all had? Okay, we don't have any kind of grid, so we're probably just going to compare positive, negative, or 0. So far, this is what of those three? Positive. Okay. All right. Then F double prime of 1. So here's 1. Okay. F double prime of 1 is, let's look at F, because it would be, if F double prime, what are we looking at? Our F is what? No. F. We just talked about that. What's going on with F double prime when F, sorry. Yes, what's going on with F when F double prime is positive or negative? What are we going to look at? Concavity, right. Okay, so F prime, or we could look at what F prime is doing. What's F prime doing at 1? That seems kind of clear. So what's the slope then? F prime, if sorry, I'm getting like a little crazy myself. Okay. All right, so let's try this again. F double prime of 1, we're looking at F, we're looking at this, right? F double, what am I trying to say here, people?
I think if you look at the slope of F prime, it'll find what
okay.
F double prime is, and then
okay.
That.
The slope of F prime, that is going to be F double prime, correct? Okay. And what is that slope? 0. At 1. Okay, wow. Phew. All right, so now you can compare a positive number with 0. This is the greater number. I think, is that what they asked? Which one is bigger? Yes, that was bigger. Oh. All right, let's talk. This is what the books look like. The book, now remember, this can be different. They did a little thing here to 2. Okay, then they did kind of a, almost a flat, concave down, and then they kind of dipped it up. So this was a 3 where you wanted to be increasing, but you also wanted to be concave down. And then at 5, they're also increasing, but you want to be concave up. So just make that pretty flat. I know Tabitha, was that you that asked me about that, or Lisa? Okay, so that's how you do that. This is concave down, this is concave up, but it's all increasing. I know that's weird. And then they kind of did a little hop, pretty straightforward, and that was at 7, where it's concave down again. And then they did up, and they just kept going. So that's what it looked like. So you had something going on at all those points. It's not very accurately spaced out, but I think you get the picture. So some of you all said, I got this weird wiggle. That was you that asked me at 3, and you should have a weird wiggle because you're going from concave down to concave up. But to make it increasing both, then that's where you have to. Okay.
Sorry, so I just need to make it slightly flat there if it doesn't
Yes.
necessarily say that
If you want to, right, because I think it's increasing from 1 to 6, isn't it? Yeah. Yeah, so from here to all the way up to here, it should be increasing. So if you got to make the concavity kind of work with that. That's what all the wiggles are. That's the concavity and increasing are about the changes in the graph. Sarah, what's your question, Darwin?
I'm just gonna say I didn't put this way wrong.
Thank you for sharing.
I just read it wrong. Like I thought the graphs were in.
Yeah. Yeah, you got to be careful about that. What's the matter? All right. Okay, so the last problem that you did, 25, any discussion on that? Did we do 25?
That was something you realized.
Yes. Yes. Yeah, because you don't know how to do that. That's really nasty to try to do that by hand, so. Yeah, you're just looking at and eyeballing that is all you can do. Did you get that figured out what you did wrong on there, Olivia?
Yeah.
Okay. All right, before we go to the notes, let's talk about the quiz real quick. This is what's on it. Okay. Derivatives by definition the long way. What are the 2 formulas that we need to know? Limit x approaches 0. What's the rest of it? I'm sorry. A. Okay. And all over. Good. That's if we know what a specific x, which is the a value, okay? If we don't, and we're looking for a function, that would be the h, bless you, approaching 0 of what? What's the function that what's the derivative definition that we're looking for now? We don't know the specific x.
Are you just asking like the formula?
Yeah.
The f of x plus h minus f of x over h.
Very good. Okay. So those are the 2 limit functions that you would need to know for the derivatives. Those are 2 definitions. This will give you a function usually. Well, not usually, always. It just sometimes might be a number too, but a number is a function. Okay? And then graphing a derivative from the graph of a function. Okay? Let's do 7. Let's do 6. Okay? Finding where function is differentiable using the graph. You're talking cusp, corners, you're talking discontinuity, and you're talking vertical tangent. Okay? And sometimes a vertical tangent kind of looks like a cusp, just slides down a little bit. This is a vertical tangent. Okay, and you're just eyeballing those. There's no function f of x involved as part of the equation. You're just looking at the graph. Yes, ma'am?
What you said we're graphing the derivative from the graph, would that be more than eyeballing the non 15 and 16, would that be exact slope?
So 15 and 16, we had F prime, we were graphing F. This is having F, we're graphing F prime. With increasing, decreasing,
So
max,
we did
min.
like exact coordinates. We would have to look at this.
Correct. Yes. You're just looking at the slopes. Those big kind of long problems where you have to say, okay, you have F, we're talking about this.
So it's more based on properties than it is based on actual, like, values.
Right, this is F. So F prime, you'd say, all right, here's 0, here's 0, here's 0. So you get, okay? And then you'd say, all right, this one's a positive, this one's a negative, this one's a positive, this one, and I'm done. So here's your derivative graph. Okay, so F prime is your derivative. Remember doing that in 2.7? That was kind of our focus. Also, we looked at this on 2.7. We had 3 graphs. Pick out the one, which one's F, like you had to do at the beginning of number 6 today. Which one's F, which one's F prime, which one's F double prime? Yes?
What you drew right there,
It kind of goes down a little bit. Either way, it kind of went, and then it kind of slid down. So that's what makes it a vertical tangent as opposed to a cusp. That's what I was pointing that out. Vertical tangents are hard to pick out. Usually, I will tell you this a vertical tangent just because they're harder to pick out. So don't worry about telling the difference between that and a cusp. If it's not identified as a vertical tangent by me, then it's a cusp. Okay? All right, and then 2.8, we did just now, finished it up. We're, using F prime and F double prime, we could go any which way with this. You could find increasing, decreasing, max, min of F. Okay? We usually don't talk about a max of F prime. Okay? So, I'm guessing around 30 points in the minor category. That would be my goal. It may not be exactly, but it'll be close. Okay? Any other questions? All right. Are you still writing, or are we ready to move on to 3? Okay. Just 3.1. This is 3.2 as well, but we're not going to get there today. We won't finish anyway. We may get more into 3.1. Your homework is just methods, no applications. They're all odd, so I assume that you're all good when you come in the door. If you're not, you would know where you're not good, so make sure you check those out. Okay, these are what we would call the shortcut rules, as opposed to, let's talk about the definition. Let's find f of x to be a constant. What's your favorite constant, Melanie? What's your favorite constant? 7. I knew you were going to say that. Okay. We're going to, by definition, we're going to have to use this. Okay. Now, this is the formula. Okay. This is going to be kind of a weird process because we don't have an x, so that's kind of confusing, but look what happens when we don't have an x. What's f of x plus h? If f of x is 7, what's f of x plus h? 7. It's weird, but you don't have anywhere to put x plus h in for x, so it's just the same. Minus what's f of x? 7. So, keep going. What's 7 minus 7? 0. So what's the limit as, if we do, remember, algebraically, 0 over h is 0, so that is 0. Okay? Now, that's a lot of work for a 0. Okay? And it's kind of confusing. So here's what you get to remember, the shortcuts. We're not going to do this piece anymore. After the quiz, we are done with this piece forever. Okay? So, for example, using the shortcut, and we know this is a constant, as in a number, not a variable. Those are opposites. Let's say f of x is still 7. F prime of x is 0. Okay? F of x is my favorite constant, number 23. A lot of things happen in my life on the 23rd. Okay? My first son was born, and our anniversary is the 23rd. So, what's f prime of x? 0. Okay? F of x is any constant. F prime of x is 0. Okay? Now let's think about this. What does f of x equals 7 look like on your graph? It is a horizontal line at 7. Y equals 7. What's the slope everywhere of that line? That's why the derivative is 0, because the derivative everywhere, the slope of this line is 0, therefore f prime everywhere is 0, because they're the same thing. Sometimes they change, but that slope is not going to change. Okay? So that's an easy one to remember, and it's quick. You don't have to go through all this anymore. After the quiz, you'll be done with that forever. Okay? Why did we do it then? Well, because we have to work with limits, because it is the basis of all calculus. All right, ready for number 2? The power rule. All right, the power rule is any number. Never mind. Any x to any power. So, for example, let's let f of x be x to the second. Okay, f of x, x to the first. F of x, x to the third. Okay, now if we were going to do the old-fashioned limit, let's just do the simplest one. Sorry, it's an h. This is the old-fashioned derivative. Okay, f of x plus h minus f of x over h. Let's let f of x be, which one of these is the simplest? X to the first. Okay, as in x. Okay. So, what's f of x plus h? If f of x is x. What's f of x plus h? X plus h. Good. And what's f of x? X. Okay. Again, that was the simplest of the 3. What's x plus h minus x? We get simplified, we get h over h. We need that long line here. What's h over h? 1. So as h approaches 0, 1, what is the answer? 1. Okay? Now that's what the derivative 1, you're like, wait, I thought you said the derivative of constant. We didn't take the derivative of constant. We took the derivative of x. We ended up with a constant, but let's see how this shortcut works. Let's do the middle one first. Okay, n comes from that. We pull n, that's n. So 1 comes around, okay, this is, sorry, f prime of x. 1 comes around, that's your n, times x to the power of n, again, 1 minus 1. What's 1 minus 1? 0. What's x to the 0 power? X to the 0 power? 1. What's 1 times 1? 1. Now, eventually, you don't have to go through 4 steps to do that shortcut. That's just showing you how the shortcut works. In this instance, n equals 1. So that's the x to the nth. Okay, so n is equal to 1. Let's try this one. F prime of x. Yes,
Why did you subtract 1 minus 1?
because that's the rule. Okay? And remember, that's what we got. We got one the long way. We got one the shorter way. Okay? Eventually, it'll be real short because you'll be able to do a lot of that in your head. All right. So what's my n this time? X squared. 2. All right. So we pull the 2 around. There's your n. And you make x to the 2 minus 1. N minus 1. What's 2 minus 1? So that really is 2x. The derivative of x squared is 2x. Okay? All right, what do you think? I'll let you find derivative of x cubed. Raise your hand when you have it. All right, nice. And that's how quick you can do it when you get used to it. Nice. Yep. Good, sir. Very good. Good. Got it? Okay. Nice. Okay. Now, eventually, we won't have to write this piece because I think most of us are probably smart enough that we can take 1 from 3 and get 2 without writing 3 minus 1. But while you're getting used to it, feel free. Okay? And be careful about your notation. F of x equals x cubed. I've seen this going on. I'm not really and then you do this. No, that's not quite what we're talking about. F prime is 3x squared. Don't say that f and f prime are equal to each other because they rarely are. Okay? So be careful about that. A lot of times we start taking shortcuts and then we take the whole name off. That's a problem. Okay? All right. That's a simple power rule, simple constant. Let's put the constant and the power rule together. Okay? Now, this is the constant multiple rule. Constant multiple rule means you are multiplying a constant by a function. U is a function. C is still that constant. Okay? And hopefully this will look familiar because we kind of did it with limits. All right. So we're going to take and grab the C, just kind of pull it out front, and then take the derivative of U per normal. Okay? So this first example is a constant, the constant 3, times a power rule, power x squared. Okay? So here's what we're going to do when we do y prime. Okay? We're going to just hold on to that. Just save it. And then we're going to take x squared and find its prime by the regular, in this case, power rule. Again, I'm just holding on to the 3. What's the derivative? That's what prime means of x squared again, using the power rule. 2x. Good. Okay. Remember, we took the 2, we pulled it around front, and we made it multiply, and then 2 decreases by 1, and x to the first. That's what we did. Okay. All right. And what's 3 times 2x? 6x. Okay, so that's y prime. Okay, now that would take us considerably longer. Let's think about this. I won't go all the way through it, but this is what you have to do if you forget the shortcut rule. You'd have to do 3x plus h squared minus 3x squared over h. It would considerably longer. 3x squared plus 2xh, blah, 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 blah. Okay? So we're not doing that anymore. We're doing the shortcut. All right, now, so the constant multiple rule is not when the constant is by itself. If the constant's by itself, it's 0. But when it's multiplied by something, we just wait and hold on with the multiplication until we're done with the other part of the derivative. Be careful that you don't get those two confused. All right, what about 5 times the square root of x? Okay, we haven't done any power, anything besides power. Can we make it square root of x a power? 1/2. There you go. Now I'm going to make this 5 times x to the 1/2. Remember a radical? There's a root in here. That's an assumed square root. So, and there's a power in here, assumed 1. So, you're going to do that a bunch, so hopefully that's comfortable. Okay, now please note it's still y, it's not y prime. All right, now you're going to try y prime with the constant multiple rule because we have a 5 that we're just going to hang on to. And then we're going to multiply by the derivative of x to the 1/2. Okay, so x to the 1/2 derivative is what? Be careful. What is it, Sarah Coffin? Which is? Very good. Okay, if you don't need to do the math as in 1/2 x to the 1 minus, sorry, that's not what I meant, 1/2 minus 1, which is where she got the negative 1/2. Don't write that. The less you have to write, the better off you're going to do, because now we have to finish it because it's not really simplified. 5 times 1/2 should be written probably as 5/2 x to the negative 1/2. This is fine. If you're really, like, I don't like negative exponents, then how would you write that?
5 over 2 square root.
Or x to the 1/2, or yes. Okay? I thought we were supposed to leave radicals in the denominator. It's really okay in calculus. Don't ask me why it's such a big deal. No worries, but no one has an issue with it anymore. So you can do any of those forms. So when you're looking at the back of the book, be sure you're like not, oh, I have a radical and they have x to 1/2. It's the same thing. Neither one is better than the other. Okay? Yes, Olivia.
On the first step, why do you put x to the 1/2 is to the first? Like that.
That's a prime.
Oh,
That's prime, as in derivative. Okay? Thank you for asking. That's prime. And I did it over here too.
do you have
That's-
to put that?
No, you don't. You can go right into the, I'm just kind of making a big deal out of the multiple constant rule. So just holding on to that. But no, you'll remember, you'll be thinking, I don't need to write that. Sometimes you do, sometimes you don't, depending on how complex it is. All right. Any other questions? Let's do the last one. Go ahead and do the last one. Now, 1 over x squared is not a power. What can you change that to? To be a multiple times a power rule. There you go. So we did the opposite of what we did when Melanie pulled it down. Now we pulled it up. But the same thing happens. We change from a positive exponent to a negative or a negative to a positive when we move it. That's all that happens. Negative 2 doesn't go anywhere, just stays there. And now you're ready for y prime. Don't forget to decrease the n by 1 when you do the power thing. And it is a negative, so. Okay. You're getting there. Very good. Melanie? What happened? Okay, remember you're multiplying that times that. There's not 1.
She really can simplify further.
Nope, it's good. Perfect. That's what I would do this. Yep, good. Perfect. Okay, so I have 2 answers showing up. 4 times x to the minus third. And I also have 4 over x to the third. Okay? Is either one better than the other? No. Depending on what you are going to do with it next, which we're done with it. So when you pull the multiple out, and you say, okay, I'm going to take the prime of -2, that makes -2 times x to the -2 minus 1 is -3. -2 times -2 is where we get our 4. And then x to the -3 is next. If you just automatically pull that down, it's fine. If you don't want to, it's fine too. Okay? So be aware that you're going to have multiple looks of the answer. Did anybody not get one of those 2 answers? Okay. So that's the multiple constant rule. We get the power rule. Sum and difference. Okay, now we're going to start putting a bunch together. We're going to put, this one's easy. We're either adding, these are 2 functions. Like this might be a power rule function. This might be a constant function. Okay? But basically all we do is take the individual derivatives and add those together. Or the individual derivatives and subtract them. So it's a real simple one. It should kind of remind you when we were doing limits and the limit laws, we could do that. The sum of the limits is the limit of the sums. Okay. Yes, so far. This is, okay, y prime. So I'm going to take f prime, x to the 5th prime, and 3x prime. Okay? I'm going to do them all individually and then add them together. All right, so what's the derivative of 5? 0, because it's a constant. What's the derivative of x to the 5th? 5x to the 4th. What's the derivative of minus 3x? What is it? Minus 3. Yep. The minus is just here. So I added and I subtracted in that problem. Remember, this is the constant and then the power rule. Okay, so the 3 just hangs on. This 1 comes around, x to the 0. That's why there's no more x anymore. So 3 times 1. That one, and now we should simplify. So what do we got? 5x to the 4th minus 3. Okay. So if it's plus, you add. If it's minus, you subtract. Please don't do the minus negative thing. We're way past that, I hope. Right? We're not doing that plus negative anymore. Okay, like they taught you in 7th grade, which was helpful for a while, but now it's just going to get in our way if we do it. So, okay? All right, try the next one. Put a little tricky thing there. We'll fall for it. What's all in there? Gotcha. You all go to college, be sure you invest in a backpack. Because you will be schlepping your stuff across campus and you don't want a big old purse. You want I know. And I get that, but when you got the big old purses, it's the same as a backpack, so.
Yeah, it has to be.
You're falling for it, Maria.
Am I?
You are, you're falling for it.
Can you tell me what part?
The last parts. All right, it's nice, Chelsea. She didn't fall for it. All right, what you kind of did, but I'm not sure what happened there. You got the first two pieces right. Yes, you're falling for my trick.
Wait, maybe give me a hint.
You fell for it too, but okay. Live prime. So far, do we have 6?
Yeah.
Minus 8x. So far, so good. Now, what's radical 2 in terms of, tell me what it is in terms of C?
Constant.
And what's the derivative of constant? So I'm done. Good job, Chelsea. All right, she's on what I saw. There's probably more of it. Anyway, okay, this is a constant. If it was a 2, you would never have fallen for that, would you have? The radical 2 is a constant as well. It's ugly, it's irrational, but it is a constant nonetheless. Okay? Good work on the other piece, though. Any questions? All right, so that's the sum and difference. Now, let me just say that you don't really have to remember this. If you're really interested in the theory part of e to the x, okay, let's just talk about that e guy a little bit. E is just as important, probably even more important than pi. That's the other irrational number. And it doesn't get the respect. The Rodney Dangerfield of irrational numbers. Okay, E is a couple different places on your calculator. In case you don't know, let me show you. We have an e to the x right here. Sorry, it doesn't show up right here. Okay. And we have an e right here. Okay. So, if you are going to do e to the x, e to some power, use this key. Use the blue key, and then that, okay? If it's just e, which is rare, then it's that. Because otherwise, you have to do blue key, division key, and then you have to do the caret key, and then the power. This will give you the power right away. Okay, what the heck is e? Anyway?
2.78.
It's 2.78-ish. It's about 3 in your head. Okay, but what it means is it's like a natural logarithm that comes up. I mean, I'm talking in nature and different things. We looked at, I don't know if we did it last year, but do you remember looking at the Facebook numbers? Okay, the Facebook numbers increased exponentially, and it was a beautiful e to the x something equation. Okay, so let's look at e to the x just to remember what they look like. E to the x, so second, this function, let me get rid of that. Oh boy. E to the x. Okay, still got to put the variable in. Graph it, and it looks like that. It's one of those that in calculus we're kind of expected to know. Okay, so let's just look at the derivative of e to the x. Is e to the x. It's an easy one to remember. Okay? So that's the derivative of e to the x equals e to the x. You're going to have some derivatives that, unless you want to go through the whole nasty limit as h approaches 0, and once we get to the trig derivatives, they get ugly fast. You have to memorize them. Okay? But memory, that's easy for most of y'all, except when you're old like me. Okay, so you got to remember this. I'll just say memorize that the derivative of e to the x is e to the x. Okay, now we're going to put some constants on e to the x. We're going to put it together with maybe a power rule. It's going to be mixed up in there with everything. Okay, so, and again, what is e? E is the base of the natural logarithm. It's the assumed base, okay? So that's what it is. E is approximately 2.78. You can kind of think of it as 3 if you really need to know, like, what is E squared? It's around 9, okay? You really need a number attached to it. Kind of think about it as a little bit less than 3. Okay, let's find y prime. Y prime is the derivative. I'm going to hold on to my 5, because I'm going to use the multiple rule. I'm going to take e to the x, and take the derivative of it, and then I'm going to take the derivative of x squared, and I'm going to subtract 2. Okay? What's the derivative of e to the x? What's the derivative of e to the x? E to the x. What's the derivative of x squared? 2x. We're done. Okay? That's as quickly as you should be able to do them eventually. And maybe you're not quite on the earthquake right now, but it's okay. Okay? So, what time are we looking at? We got about 15 minutes. I can do. Yes. Let me do one more example. For each of the x plus 6x squared minus 5x plus 13. All right, find y prime. When you get really good, you better write it and think it is done. Nice. Good work. Okay. What's y prime? 4e to the x plus 12x minus. Huh? Did I say 8? So, why am I doing an 8? So it's minus 5, right? Where did you get the 8, Melanie? Right?
I pushed the 13.
Okay. Yeah, 13 derivative is 0. Now I saw Lauren when she was writing this out. She wrote, did you write this one out?
Yeah.
Okay, but then she did this because she wanted to think about that one. Did you do this one? But then she did 0. Because she's like, ah, that's a constant. I'm not going to drag it around. So that's smart. Okay? So just whatever you think about, if you can do this without writing that, which I hopefully you'll be able to do that pretty quickly after the homework assignment, then just do it. Just write y prime and write it and be done and move on. You don't have to tell me how you're getting it. I know how you're getting it. Okay? And the less you have to write, the better off you're going to be. I'm going to